Okie dokie, so this is my gift to my algebra class. So it says, choose 3 exercises on this side and 2 on the other. Make sure that you provide valid mathematical arguments to structure your response. Okay, so valid mathematical arguments. So let's start with the first one. All right, so it says, Mr. Spellman expressed radical 450 in simplest radical form. He claims that the result will be 3 radical 50. Okay, is he correct? Can you connect the dots and explain his reasoning? Is there a more elaborate plan or more steps needed? Can the radical be simplified even more? Well, for that, you might want to use a loose leaf or a piece of paper, because you need to work the problem out in order to actually write an elaborated explanation. So let's see now. This is what he was given, right? And this is what he claims. See, he claims that this is the same thing as 3 radical 50. So your job is to prove that he's correct, disprove that he is correct, explain maybe he's halfway done. Well, we don't know. We're gonna find out right now. So let's see, 450. How did he get 3 radical 50? Well, I know that 450 is going to be radical something times radical 50 according to Mr. Spellman. Now, what is this in here? Well, think about it. These 3 came out of the square root of something. 3 must be the square root of 9. And if you check on the calculator, 9 times 50 is actually 450. So radical 9 times radical 50 is radical 450. So far, so good? Okay then. So that's where he gets 3 radical 50. But then again, radical 50 can be simplified even more. So how do you read this? 3 times radical 50. So 3 times, and then how do I simplify radical 50? Well, radical 25 times radical 2. Okay. Tuti. ¿Qué onda? Okay. So, sorry. So now, this is radical 50, remember? So then this is 3 times, okay? The square root of 25 is 5. Some of you think that the square root of 25 is 5 and then you put the square root symbol again, and no, that's it. That's the reason you got rid of it. Times radical 2. So then 3 times 3 times 5 is 15. And you got 15 radical 2. So this is the simplest form of radical 450. Okay, so then now I know that Mr. Spellman is not completely incorrect, but he's also half correct because he forgot to simplify radical 50. Okay, so now to write our explanation. Okay, to write our explanation. Here. All right. Mr. Spellman is not completely correct, okay, nor is he incorrect. Okay, he simplified radical 450 into radical 9 times radical 50, because that's what we have, right? Yielding or resulting yielding in 3 radical 50. But he forgot to simplify. He forgot to simplify radical 50 into radical 25 times radical 2. Okay? Which is equal to 5 radical 2. Okay, now the whole expression or the whole yeah, the whole expression becomes the 3, okay, 3 from here times, okay, radical 50. That radical 50 now is 5 times radical 2. And this is equal to 15, or which equals, you could write that 15 radical 2. Okay? Now, a different approach would have been, okay, a different approach would be, okay, a different approach would be to choose different factors. A different approach would be to simplify radical 450 into radical 225 times radical 2, okay, which is equal to, okay, the square root of 225 is 15, and then radical 2. Okay, so this is a written explanation providing mathematical evidence for your claim, what you claim, that he was not completely correct nor is he incorrect. Okay, he forgot to simplify radical 50, blah blah blah, and there you go. All right, let's move on to the next question. I'm gonna have to do all the questions because I really don't know which are you going to choose. Ooh, come on, I'm wasting time. All right. So, which expression is equivalent to 7 radical 90? Construct a mathematical model that justifies your response. All right, so mathematical model. First of all, I don't believe in multiple choice, so I am going to do it by hand. And that is the mathematical model that I'm going to do. So, to simplify, To simplify 7 radical 90, we need 2 factors of radical 90. Okay, with one of them, with one being the largest perfect square. Okay, with one of the factors being the largest perfect square. So let's see, radical 90, okay, radical 90 is equal to radical 10 times radical 9. So what do we have? So 7, the 7 from the radical 90, right, times radical, in this case I'm going to put radical 9 first because I know that that's the perfect square, times radical 10 equals 7 times radical 9 is 3 times 3 times radical 10. Okay, which equals 21 radical 10, making our answer choice number 2. Okay, provided mathematical model right here. Okay, next one. What type of number results from the product of two irrational numbers? Provide mathematical argument to support your claim. Well, I'm going to give you an example very quick. Let's see now. Radical 2 times radical 5 is radical 10. That's irrational, correct? Pi times pi is pi square, which is irrational. Then, watch this. Radical 2 times radical 8. This is irrational, this is irrational. But when I multiply, I get radical 16, which is basically 4. And 4 is a rational number because it can be written as 4 over 1 as a fraction. Get it? Okay then. So in conclusion, I did multiply two irrational numbers and I got irrational. But then I continue and I still got irrational. But then I continue, and when I multiply two irrational numbers, the product, the multiplication, was rational. So then what does that say about multiplying two irrational numbers? Okay. When two irrational numbers are multiplied, when two irrational numbers are multiplied, the product can be rational or irrational. See that? Okay. The following mathematical evidence will or proves that. How do you say that? Proves that. Proves this. So now provide mathematical evidence. Okay, example A, or example. Radical 2 times radical 5 equals radical 10, which is irrational, right? Example B. Pi times pi is pi squared, which is irrational. Okay, so far. But in example C, radical 2, which is irrational, times radical 8 is equal to radical 16, right? Which is 4. And 4 can be represented as 4 over 1. Therefore, 4 is rational. Got it? Cool that. I really write ugly, but that's actually the pen. Let me try a different pen. Maybe this one works better. Oh, okay. So now, let's move on to the next problem. All right, so here, when two irrational numbers are added or subtracted, the result is irrational. Provide mathematical evidence to prove or disprove the given statement. Okay, so here I'm gonna provide mathematical evidence. So I'm gonna write the result can be mostly can be irrational, and in some cases rational. Okay, example A. Two irrational numbers. Okay, so let me see now. Let's say two irrational numbers. Well, an irrational number is a number that doesn't end and doesn't repeat. So pi plus pi equals 2 pi, which is irrational. Irrational. But then again, remember, subtraction is the same thing as addition of an opposite number, of a negative number. So look, pi plus negative pi. You see, I'm adding two irrational numbers, or this can be the same thing as pi minus pi, or I am subtracting two irrational numbers. However you want to look at it, the result in this case is going to be 0, which is what? Rational. Okay, next. Simplify the following polynomial. Alright, so I'm gonna simplify this polynomial. First, I gotta remove parentheses. Here, there is a 1 outside, but I don't need to do anything. Anything times 1 is itself. So this just becomes 3p plus 1. Then here, I have to use the distributive property. Okay? So, positive 6 times p is positive 6p. Positive 6 times negative 8, negative 48. And now guess what? Whenever you see a negative, okay, and then the parentheses, I know that this right now is a subtraction, but we could remove the parentheses from there too. Look, you're gonna distribute the negative over the parentheses, the addition. So negative times p is negative p. Negative times 2 is negative 2. You see that? Alright then, so I have removed parentheses, and now all I have to do is regular third grade math. So let's see. 3p plus 6p is 9. Oh, you know what? Easy. Forget it. Let's combine like terms. So we're gonna use the commutative property to switch the like terms and put them together. So 3p plus 6p minus p plus 1 minus 48 minus 2. So now we combine like terms. 3p plus 6p is 9p. 9p minus 1p is 8p. Then we have the natural numbers. 1 minus 48 is negative 47. Negative 47 minus 2 is negative 49. And that's it. Alright? So now, let's turn the page over. Let's see what we have here. Alright. So here you're going to basically choose two problems. That's what it says, right? Choose two problems on this side. Okay. So what I did is, it says, find each sum or difference by combining the parts that are alike. What strategy or property did you use? Explain. Sure. So I'm giving you this example. Okay? And it says, this is a polynomial expression, and I need to simplify it by using the distributive property here, right? on negative 12 times n minus 3. So next I'll write the resulting polynomial expression. So for m plus 6, I remove the parentheses, you see that? Then negative 12 times m is negative 12m. Negative 12 times negative 3 is positive 36. Plus, and then here there's nothing to do, so I remove the parentheses. If this had been a negative, then I would have distributed the negative, but it's a positive, then everything is kept the same. All right, so then the explanation right here. I remove the parentheses after applying the distributive property, and now I'll combine like terms. So now look, I use the commutative property to put the like terms together. See that? And then the resulting polynomial is, well, 4 minus 12 is negative 8. Negative 8 plus 1 is negative 7. M. And then natural numbers. 6, 3, and 2. The 6 plus 3 is 9, plus 2 is 11. So we got that. So then that's exactly how you're gonna tackle each of the problems. That is the exact explanation that, well, not exact explanation, but I need you to write in full sentences. So I need you to basically do this. I'm gonna do one of the two problems that you need to do. I'm gonna do this one, which is complicated. All right, now you have to write the explanation. I'm not gonna write the explanation right now. I'm just going to help you do it, and then whatever I say, you might try to put it in writing. All right, so this is a polynomial expression and I need to simplify it. Okay, so I will use the distributive property twice. I'm gonna use it right here and I'm gonna use it right here. Here there's nothing, okay, there is no negative sign here, so I'm good with that. Okay, so I write 5 minus t. If you are writing what I'm writing right now, I'm gonna mark it wrong because I said you need to provide this explanation, okay, to the best of your ability. So everything I'm saying you might want to write. So 5 minus t squared, that's it, I remove it. This is a plus, but I have to use the distributive property because I have a number. So positive 6 times t squared is positive 6t squared. Positive 6 times negative 8 is negative 48. Okay? And then here, look at negative and then the parentheses. That means I'm going to distribute the negative and I'm going to use the distributive property. So negative times t squared is negative t squared. Negative times 12 is negative 12. Now I'm going to use the commutative property to put like terms together. So I get negative t squared plus 6t squared minus t squared. And now the regular natural numbers. Positive 5, negative 48, and then negative 12. Okay, now let's see. Negative 1t squared, these are negative 1, right? 1 plus 6 is 5, or 6 minus 1 is 5. 5t squared minus 1t squared is 4t squared. And then 5 minus 48 minus 12, you know what to do. Remember, write a little smaller so your written explanation fits in there. And this is my gift to you. I hope you appreciate that. And I'll see you tomorrow Friday. Okay? Gucci.